When NOAA's GOES-U satellite is launched in 2024, it will be the final satellite in a heralded NOAA satellite program and a bridge to another future age of advanced satellite technology. For nearly 50 years, NOAA and NASA have partnered to develop and advance NOAA's geostationary satellites as part of the most sophisticated weather-observing, environmental monitoring, and space weather monitoring satellite system in the world. When GOES-U reaches orbit, it will be the culmination of nearly 5 decades of state-of-the-art geostationary Earth-observing satellites. It all began back in October 1975. For the launch of NOAA's GOES-U satellite, which monitored our weather and space weather.
We've come a long way in weather forecasting since the early balloon launching days, thanks mainly to weather satellites. With each succeeding one, these weather sentinels have become more and more sophisticated. Here, the synchronous meteorological satellite. 2 are already in orbit, with a 3rd scheduled for launch this fall. The synchronous meteorological satellite pictures are made into film loops daily. Meteorologists are hopeful that this kind of information will give them clues to the weather conditions that, for instance, cause tornadoes and other fast-moving weather systems.
As groundbreaking as it was, it had limited capabilities and only viewed Earth about 10% of the time. By 1980, a new series of GOES satellites went into orbit. These satellites had the capability to obtain vertical profiles of temperature and moisture throughout the various layers of the atmosphere. This added dimension gave forecasters a more accurate picture of the intensity and extent of storms and allowed them to better monitor rapidly changing events and make more accurate predictions. In 1994, GOES-I was launched, and with it came significant improvements in the resolution, quantity, and continuity of GOES imagery and data, thanks to a new 3-axis method of stabilization. Once it reached orbit, it was renamed GOES-8 and gave forecasters more accurate information to pinpoint locations of storms, wildfires, and other hazards. By the mid-2000s, GOES-N, GOES-O, and GOES-P further improved the imager and sounder resolution to better pinpoint the locations of intense storms. This satellite series also had improved optics, better batteries, and more power, allowing for more continuous imaging.
3, 2, 1.
Then in 2016, the current generation of geostationary satellites was launched, the GOES-R series. With this series came new advancements that included state-of-the-art instruments like the Geostationary Lightning Mapper and the Advanced Baseline Imager, or ABI.
When we got the GOES-R, I remember sitting on the forecast desk and seeing some of the earliest data, and it was a game changer. An absolute critical part of our forecast process to see that ABI and actually track cloud movements and track how much moisture's in clouds. It was amazing. And it enables us to look at phenomenon like atmospheric rivers and be able to help us with the forecast for the flooding, the amount of rainfall. And on the front lines at the National Weather Service, we provide decision support. And so to have that information from GOES-R, it really enabled us to communicate information to decision makers for them to make really tough decisions.
Well, we knew the technology was going to be game-changing. We knew the ABI with its capabilities, and then the Geostationary Lightning Mapper, which was a brand new instrument. We knew that was going to be revolutionary. We even thought it's so new that there's probably going to be new applications, but the range of new applications that people have found have really surprised me. We found over time that ABI can detect turbulence, so it can really look at a patch of sky and see when there's going to be turbulence for aircraft flying through it. We've recently found that ABI can actually detect large methane leaks, so it can tell when something is going wrong in a plant, a refinery, and be able to track that feature.
Space weather monitoring has also been part of the GOES mission since its inception. So after GOES-U, what's next for NOAA's geostationary satellites? Its planned successor will be a state-of-the-art satellite series called Geostationary Extended Observations, or GeoXO. The first GeoXO satellite is expected to launch in the early 2030s as the GOES-R series nears the end of its operational lifetime. Like GOES-R, GeoXO will continue NOAA's 5 decades of critical Earth-observing data. GeoXO observations will allow scientists to better monitor environmental conditions and will complement observations from other satellites from NOAA, NASA, and our international partners.